And welcome back, students. We are now going to get into hardware. We're going to start off first by discussing the motherboard. So, getting started, let's recall that the motherboard is the main printed circuit board of the computer. Specifically, this term refers to expansion capability. This board is often referred to as the mother, therefore, of all components attached to it, which includes things like peripherals, interface cards, and any quote-unquote daughter cards. So like your sound cards, your video cards, network cards, hard drives, and any other forms of persistent storage like your hard drive. Alright, design. Now, a motherboard provides the electrical connections by which all the other components of the system communicate. It also contains the central processing unit, or the CPU, and hosts other systems and devices. Again, this is your main printed circuit board. Everything is physically connected into this circuit board. A typical desktop computer has its microprocessor, the main memory, and other essential components connected to the motherboard. When we look at like an ATX board, we're going to look at, and we'll talk about the different components and we break down stuff there. You'll start learning about some of what those different things do. Other components such as external storage, controllers for video, display, and sound, and peripheral devices may be attached to the motherboard as plug-in cards or via cables. In modern microcomputers, it's increasingly common to integrate some of these peripherals into the motherboard itself. So that's why, for example, you'll have like onboard video or onboard audio, or even onboard networking are all integrated into that motherboard. Continuing to talk about design, an important component of a motherboard is the microprocessor supporting chipset, which provides the supporting interfaces between the CPU and various buses and external components. This chipset determines to an extent the features and capabilities of that motherboard. So let's then use that in mind to talk about some of the components. So modern motherboards include sockets in which one or more microprocessors may be installed. In the case of CPUs in ball grid array packages, the CPU is directly soldered to the motherboard. You also have slots into which the system's main memory is installed. This is typically in the form of DIMM modules containing DRAM chips. You have a chipset which forms an interface between the CPU's front side bus, main memory, and peripheral buses. You have non-volatile memory chips, which is usually flash ROM in modern motherboards, which contains the system's firmware or BIOS. You have a clock generator, which produces the system clock signal to synchronize the various components. You have slots for expansion cards, the interface to the system via buses supported by the chipset. You have power connectors, which receive graphical power from the computer power supply and distribute to the CPU, chipset, main memory, and expansion cards. Some graphical cards require more power than the motherboard provides, and thus dedicated connectors have been introduced to attach them directly to the power supply. So if you're, for example, a gamer and you buy a new, let's say, at the time of recording this video, let's say you get a NVIDIA GTX 1080. Those are going to have their own need for power, so you're going to have to, you can't just reach off of the motherboard power. You have to physically plug that graphics card into your power supply because it needs more power than what the motherboard can carry. You have connectors for hard drive. These are typically SATA cables, which we'll look at when we start talking about those different things. And disk drives also will connect to the power supply because they need power in order to physically run. All right, let's talk a little bit about the design. Additionally, nearly all motherboards include logic and connectors to support commonly used input devices such as USB for mouse and keyboard. Now, given the high thermal design power of high-speed computers, CPUs, and components, modern motherboards nearly always include heat sinks and mounting points for fans in order to dissipate that excess heat. Remember when we talk about the components, so the CPU, for example, typically has a fan mounted right off top of it to blow that hot air off. If you have a graphics card, they typically have a fan to help blow that hot air off. Anytime you start adding in stuff that requires a lot of heat generation, it's going to have a fan. Now we need to talk also about the form factor. Motherboards are produced in a variety of sizes and shapes called computer form factor, some of which are specific to individual computer manufacturers. However, the motherboards using IBM-compatible systems are designed to fit a variety of cases. As of 2007, most desktop computer motherboards use the ATX standard form factor. Now, there is a BTX form factor, which is relatively new, but it hasn't really been adopted. In fact, most motherboards are still following the ATX. A computer's motherboard and PCU form factor must all match. Though some smaller form factor motherboards of the same family will fit larger cases. So you can take a mini ATX and plug it in, assuming you have the correct pin sets. Right, continuing to talk about form factor. When we look at, for example, a laptop, because remember those are one of the different types of computers we talked about. These generally use highly integrated, miniaturized, and customized motherboards. Because remember, it's got to fit into its own special space. Now, this has the advantage of making everything fit in a laptop. However, this is one of the main reasons why laptop computers are very difficult to upgrade. And they're expensive to repair because everything is so individualized. It's not like a desktop computer is like, oh, my one of my memory sticks has gone bad. Well, let me just pull that RAM stick out and I can put a new one in and it fixes the problem. It's a little harder to do that on that of a laptop. Now, because of this customability, the failure of one laptop component requires the replacement of the entire motherboard because everything's been customized specifically to that board. All right, which replacing is usually more expensive than that of the desktop motherboard due to the large number of integrated components and their custom shaped size. Let's talk about the CPU socket next. A CPU socket or slot is an electrical component that houses, or that attaches, to the printed circuit board and is designed to house the CPU. So it's literally a square, typically, on your motherboard that your CPU will connect to. The CPU socket provides many functions, including a physical structure to support the CPU, support for a heatsink in the form of pins that you can connect in, facilitating replacement, and forming an electrical interface both with the CPU and your printed circuit board. Printed circuit board referring to that of the motherboard. Now, CPU sockets on the motherboard can most often be found in most desktop and server computers. Laptops typically use what's known as a surface mount, and particularly those based on the Intel 86X architecture. A CPU socket type and motherboard chipset must support, of course, the CPU series and speed. In other words, you can't just take any old CPU and stick it in with a motherboard. It's not going to work. There's a certain level of compatibility. So, for example, Intel boards have to have an Intel chip. And even then, you still have to have an Intel board that your CPU is going to match to. So that's why if you're ever doing custom building your own, you got to make sure that they have compatibility. Next, let's talk about some integrated peripherals. With the steadily declining cost and size of integrated circuits, it's now possible to include support many peripherals on the motherboard. Things like disk controllers for floppy drive, up to 2 PATA drives, and up to 6 SATA drives. Right? Of course, yes, some of those things are kind of no longer really being used, like floppy drives. Even PATA drives have kind of gone out in form of SATA. You have integrated graphics controllers which support 2D and 3D graphics with things like VGA support. Integrated sound card, which typically supports up to 8-channel audio or S/PDIF output. You have a fast Ethernet network controller for 10/100 megabit networking. Some of the new ones may even each up to 4 gig if you're lucky. USB 2.0 controller supporting up to 12 USB ports. Newer computers will even support up to USB 3.0. IRDA controller for infrared data communication. Temperature, voltage, and fan speed sensors allow the computer to monitor the health of computer components, which is very, very good thing because the last thing you want to do is if something gets too hot, your computer wants to be able to shut it down to prevent further damage. Now, the advantage of doing these different functions and integrating them onto the motherboard rather than having separate components for each is that the physical size and the total cost of your system may be reduced. Because now it's all just on one chipset rather than on multiple. Highly integrated motherboards are especially popular in small form factor and in budget computers because you don't have to buy the individual components. Let's talk about those peripheral card slots though. A typical motherboard will have a different number of connections depending on its standard and form factor. A standard modern ATX motherboard will typically have 2 or 3 PCI Express 16X connection for a graphics card, 1 or 2 legacy PCI slots for various expansion cards, and 1 or 2 PCIe X, which is superseded PCI. A standard ATX motherboard, so this is a different variation, will have 2 to 4 PCIe 16X connection graphics cards and a varying number of PCI and PCIe slots. You can also sometimes have a PCI 4X slot, which will vary between brand models. Now, some motherboards have 2 or more PCIe 16X slots, which offer things like 2 more monitors without special hardware, or use special graphics technology called SLI for NVIDIA or Crossfire for AMD. Now, what these do is they allow for 2 to 4 graphics cards to be linked together and to allow better performance in intensive graphical computing tasks such as gaming, video editing, etc. Now, temperature and reliability. Remember I talked about the sensors wanting to shut the computer phone down if it gets too hot? Motherboards are typically air-cooled, with heat sinks often mounted on larger chips and other motherboards. This is because insufficient or improper cooling can cause damage to the internal components of the computer or cause it to crash. Passive cooling or a single fan mounted on the power supply was sufficient for many desktop computers up until about the late 1990s. What happened then? Well, then we started putting things like sound cards in, we started putting video cards in, and all of a sudden, that single fan wasn't going to meet the needs anymore. Today, CPU fans are required and are mounted on top of their heatsinks due to rising clock speeds and power consumption. Most motherboards have connectors for additional fans, integrate temperature sensors to detect motherboard and CPU temperatures, and controllable fan connectors which the BIOS or operating system can use to regulate their fan speed. Now, alternatively, computers can use water cooling instead of multiple fans, but it's a whole different ballpark. Now, some small form factor computers and home theater PCs designed for quiet and energy-efficient operations boast of fanless designs. Now, the reason they do this is, or how they do this, I should say, is it typically requires the use of a low-power CPU, as well as careful layout of the motherboard and other components to allow for heat sink placement. So it distributes the heat a little differently. Bootstrapping the BIOS. Motherboards contain some non-volatile memory to initialize the system and load some startup software using an operating system from some external peripheral device. Now, microcomputers will use ROM chips mounted sockets on the motherboard. At startup, the central processor would load its program counter with the address of the boot ROM and start executing instructions from them. These instructions are initialized and then test the system hardware, displaying system information on the screen, perform RAM checks, and then load an initial program from the external or peripheral device. If none of these things were available, then the computer would perform tasks from other memory stores or display an error message, depending on the model and design of the computer and ROM version. So, some of you may wonder, I don't know what this means. It sounds like a little bit of, gibberish, or it's all going over my head. Just think about when you first turn on a desktop computer and it runs like the series of checks, and you see like a bunch of like text pop on the screen, or you'll see like just like the logo of the manufacturer pop up, I guess like HP or Lenovo or Dell, and just sits there as it runs through this check. You don't see it doing necessarily all these checks, but these things are happening behind the screen. All right, now most modern computer systems designed use a BIOS, which is stored in an EEPROM chip, which is typically soldered to or socketed on the motherboard, which then boots to an operating system. So the BIOS is like your first operating system, which once it does its thing, then it boots into your main operating system like Windows. Non-operating system boot programs are still supported on modern IBM PC descent machines, but it is assumed that the boot program will be a complex operating system, such as things like Microsoft Windows and Linux. All right, let's continue to talk about bootstrapping. When power is first supplied to the motherboard, the BIOS firmware tests and configures memory, circuitry, and peripherals. So that's when you turn it on, you have that initial screen. It's going through and running a test on everything to make sure that the initial hardware pass is going to be okay. This power on self-test may include some testing of the following things, or what's also known as a post-test. So test your video adapter, make sure that it's getting a video output. It's going to test your cards inserted into slots, such as conventional PCI. So if you have, for example, a graphics card or some specialist networking card that might be plugged in there, it's going to test those, make sure that there's no errors. Test floppy drives. It's going to test your temperatures, voltage, and fan speeds for hardware monitoring, because it wants to make sure that your computer gets hot and it can shut something down if you need to. CMOS memory used to store BIOS setup configuration, so it's going to test to make sure your CMOS memory is still good. The keyboard and the mouse, your network controllers, any optical drives that you have, SCSI hard drive, IDE, eIDE, or serial ATA hard disk drives, security devices such as fingerprint readers or the state of the latching switch to detect intrusion, USB devices such as memory storage, and that's it. That's everything that we have to talk about before motherboards today. I know it was quite a bit, but when we come back next time, we're going to start delving into a little bit more specifics about the motherboard. We're going to start looking at some of the different components and some of the different circuitry stuff that is on a motherboard. So until next time.